Hello, hello, children, people of Enriched geometry. We are on measuring angles and arcs. So after today, you're going to be able to find the measure of angles and arcs of circles. Yes, you will be able to. Have some things we got to talk about first before we can get into it. So here we go. We have central angles. So a central angle is an angle with its vertex at the center of the circle and its two sides are radii. The sum of all the central angles in a circle is 360 degrees. Let's back up a second here. So a central angle has its vertex at the center. So here's my vertex of this angle. And then the rays of your angle are the radii. So this would be a central angle here, angle ABC. Okay, so angle ABC is a central angle again because it's center. The vertex is the center, and then the rays, the sides of your angle are radii. Okay, and now all of the central angles in a circle add up to 360, and that should be kind of like a duh moment for you, right? Because we know there's 360 degrees in a circle, and if you put a bunch of different central angles in here, if you add all of these up together, you would get 360. Okay? Shimmy down here a bit. The degree of an arc is formed by the endpoints of the central angle is equal to the degree of the central angle. So, do you guys see how we have this arc that is formed? If I were to ask you the degree of that arc, it's the same as the degree of that central angle. So this would be 84. Okay? 84 degrees. We're going to run out of space here, but that's what this is saying here. So the measure of arc AC, so what I just highlighted in blue there, is equal to 84 degrees. So it's equal to the central angle that it's made. Now we're being asked to find the measured angle, of arc ABC. So if I trace that out, I start at A, go towards D, and hit C. We're looking for this big red arc. And you want to know what's the degree of that? Well, what's left over of our 360, if we take 84 away, you should get 276. So that would be the degree of that major arc. Now, we can classify arcs in a couple different ways. The first one is a minor arc. So a minor arc is an arc, I'm going to make this a little smaller here so you guys can see it in one screen. Okay, so a minor arc measures less than 180 degrees. This is crucial. We use two letters to name it. So it has to be less than 180, so like arc EA. That would be a minor arc. Okay, or CB. That would be one, or I guess even AB. Or you could get real fancy, folks, and go from like B all the way to E. As long as it's less than 180, it's considered a minor arc. So I'm assuming you probably guessed this, but a major arc is an arc greater than 180 degrees. And we use three letters to name this. So I have to be greater than half the semicircle, or half the circle, right? So if I wanted to do like this guy here, I would call this arc A, pick one of the points in the middle, let's do D, and then it ends at C. And then if I wanted to do, let's say this, if I wanted to trace out BCE, you start at the first letter B, and you go towards the second letter. So since I want to go towards C, I'm going to go down, and then I end up at E, okay? So this tells you the order in which way you go in your circle. Okay, so the order does matter. It tells you where to go. And then lastly, a semicircle measures exactly 180 degrees, and you use three letters to name that. And how you know if it's exactly a semicircle, there will be a diameter, and that splits it, right? So then I would know that arc EDC here would be a semicircle, or you go the other way, EBC. Again, both of those are semicircles. So let's practice a bit with these ideas here. So it says, for each angle or arc measure, identify the arc as minor, major, or a semicircle. So we're first going to find the angle or arc measure, and then we're going to classify it as a minor arc, major arc, or a semicircle. These connected? Of course they are. Okay, here we go, folks. So we want the measure of arc. That's how you know we're talking about an arc right there, JK. So its measure would be the same as its central angle, so it's 21. And since it's less than 180 degrees, it's minor. We want the measure of angle JNM. JNM. Okay, so I want that angle measure. I think we have a straight line here. So this would be 180. So if we take 180 and subtract 21, we'll get 159. So the measure of that is 159. And then since it's still less than 180, it's minor. Okay, let's erase here. KL here. So I'm going to put what we had there, 159. What's nice, you guys, is we can still use old information that we know. Look, we have vertical angles here. So if this is 159, so is this. So we know that arc KL is 159, and it is still minor. JKM. J to K all the way to M. So this is going to be a major arc. We know it's over 180, right? Because this would be my 180 threshold, and then we're adding this 21 more degrees. So 180 plus 21 gives us 201. So that's major. And then our last one here, folks, MKL, MKL. Oh boy, we're going all the way around. So we're looking for everything but this chunk here. And again, we have vertical angle, which is helpful. So if this is 21, so is this. So you want everything but that 21 degrees, which gives us 339. So 339, and it is major. It's bigger than 180. I think this next would be a good time for you to pause the video and try this for yourself. But again, oh shoot, don't look. Command Z. You know you can pause it. Yeah, you should try this on your own and see if you get the correct answers here. So I hope you pause it. We'll go through it quick. PQ, this guy right here. Well, we know vertical angles, this would be 19. So 90 minus 19 would give us 71. So that is why PQ is 71, which makes it minor. SR, this guy here. So 180 minus 19, folks, should be 161, which makes it minor. QRT. Q to R to T. Let's use green. Q to R to T. So 19 plus 161 should give us 199, which makes it major. PSR. PSR. P to S to R. So we're going to the left. Oh boy. So basically everything but that right angle. So 360 minus 90 should give us 270, which is major. And then PS. So this would be 90. And then we have plus 19 more. So 90 plus 19 would be 109. I hope that went okay for you. Again, if you're lost, we will do some more examples in class when I see you. And then the last thing that we can do with arcs is find their arc length. The length of an arc is a portion of the circumference. So here's our formula, but let's break it down so it makes sense for you. We know that the circumference formula is 2 pi r. So that's where this comes from, because that's my circumference. Now this piece here tells me the portion I want of my circle. So if we were given an arc of 27 degrees, we could find out its length because we plug in 27 there. That would give us the portion of the whole thing. So you take your circumference times the portion that you want. So find the length of arc AB. Here's AB. So our formula, I'll write it down here. Now we just plug in what we know. So my radius is 3. My angle's 45. And now we go from here. Again, this is calculator work. You simplify how you want. I'll show you what I did. 2 times 3 is 6 pi. 45 divided by 360 is 0.125. And now I just multiply those together in my calculator to get 2.35. So I don't know, we could say 2.4. And then it's just a linear length, so just centimeters. It's part of your circumference, so it's not squared or cubed, it's just regular centimeters. And then our last one here for notes, we're looking for AB. So again, our formula. Oopsies. So 2 pi, our radius is 7, right? Half of 14. Our angle is 80. Again, you do you. 2 times 7 gives me 14 pi. 80 divided by 360 is 0.22. Crunching that out, 9.76. So like 9.8 meters. All right, thanks for making it this far in the video. I appreciate you so much. Just think, savor these moments. We only have a few videos left together. Have a good rest of your day, and I will see you in class. Goodbye.